So, good morning, everybody. Very pleased to see you all here. That means you're very passionate, right, to go to the snow and everything to get here and, be present on this nice day. So thank you very much for that. My talk is about the secure software development lifecycle, and basically there is only fun and boring. Who knows the quote, actually? Nobody? No, really? Oh, it's from the movie Hackers. Come on! Okay, homework. Watch tonight the movie The Hackers. It's nice and old school from the 90s, so everybody can relate probably, right? Okay, not for you. And they didn't make movies in the 50s or how? All right, so let's start. Who am I? I'm Glenn. I used to play this game a lot. Unreal Tournament, more than 30 years ago. That's actually how I started doing security in IT, sort of. Here what I did was basically build an aimbot and then shoot automatically on people's heads. Probably if you play the guild, you get monster kill, ultra kill, and then you get godlike. Yes? Okay, so that was me doing stuff like that when I was like 13 years old. I made from security my career, currently working at ING as a security chapter lead. Also very involved in the open source community at OWASP, of course, and together with my brother Ricardo, we actually created an OWASP project, the Security Knowledge Framework. And this I will demonstrate as well in a bit later. So when we talk about the secure software development lifecycle, and specifically a little bit from a security point of view, we have, of course, a couple of topics that are really important, right? Take, for example, the security requirements phase, where I have other great OWASP projects like the MASVS for mobile, and also for web API development, the ASVS, right? The Application Security Verification Standard. What is also important is, of course, your test automation and code quality, something we don't actually do that much, unfortunately, but, just to highlight, if you have a lot of dead-end code and you're doing code reviews, well, that's a waste of time, right? Looking at code that's actually not even used. The other thing, of course, is over-complex code, especially when we talk about more than 50% of the vulnerabilities. They are all related to business logic, right? So, if your business logic and your over-complexity of that code is huge, then probably that is where all the creepers are in, and your business logic vulnerabilities. But also repudiated code, of course, that can be an issue. Security test automation, very important topic, right? I mean, we like to automate things, find things, and that's really awesome. But there's still some problems with it. And you might know, people who already are doing this and playing with this, what is actually the problem. We have SOST and DOS tooling in that area, right? The static code analysis and dynamic. We have also a sort of, I would say, new kid on the block, the EOST, the interactive security testing. Still, I would say all these topics that I'm now discussing are very key, important to do, but there are some challenges with that. And I also want to highlight those today. And the other thing, of course, is the manual verification, right? It's all nice that you have these tools and all the things and the requirements, but at the end, you also want to do regular implementation checks. Really, somebody looking at it, from a real person point of view, right? And find the missing pieces and the implementations, verifications. So if we go even a bit broader, I would say, why are we all doing this, right? Why are we doing security and testing and all that good stuff? Because we're actually building a product that needs to have a certain measure of quality, right? And as you can see from the slide, where is it? Over here, we have also security. And as you can see, it's just a piece of the pie when we talk about application quality and software quality that we deliver. Also from all the other areas of this pie, you will see that they all could correlate back to security as well, right? So when you want to build a good quality application, you should really consider this approach. And of course, you can say, hey, I'm not able to do all of them, but at least make a good decision in what you want to achieve and what not, and utilize and create that capability then to ensure the quality of your product. Which is security, of course, an important thing but I just want to mention it. Now, we are all in the DevOps train, and we like DevOps because we can automate things, we can release faster. That's really cool. Very nice, but we have some challenges there, right? So what do we gain and what do we want with the whole DevOps is, of course, getting fast feedback loops, fast releases, empowerment of teams that can release quicker. But also, we can use this to build applications more secure by design, because we have really feature-focused releases. And also with these small releases, we can also hopefully remove and keep on par with technical debt. Because remember, when we did waterfall development, you developed something, a half year later you deployed it. Well, if you're going to do that again, or even at that moment, probably what you have built had already a shitload of technical debt, right? So, yeah. And what I also notice is that most of the companies, when we talk about technical debt and, fixing things, mostly their sprint planning looks like 90 or sometimes 100% full with feature. That's like what? Not a good thing, right? It should be at least like 30% dedicated for features, X% dedicated for ad hoc stuff that comes, because, hey, that shit happens as well, right? Then the other 25% or whatever for eliminating technical debt, and the other maybe for improvements and building automation around other tasks that you normally have to do all by hand. So that looks very different, that pie, than currently what I'm seeing in all the companies, right? What they're doing, which is only features. And I get it, because they want to deliver, right? They want to add features. The features mostly result into more money, more profit, good for the organization, for the company. But yeah, let's not forget, if you have technical debt or get hacked, or what is then the use, right? For the people who are not aware, so what is a SAST? SAST is basically a static analyzer, right? It looks from the source code of the application and then finds vulnerabilities in it. Then we have DAST, that is basically looking at the dynamic running application and finds vulnerabilities in it. It's like scanning it. And then we have a new one, sort of, it's the interactive one, and that actually deploys sensors in your source code and connects the dynamic part to the source part. So very cool, different security tools. I would say definitely we're going to use them, and also, whatever fits your boat, right? It depends on your stack, your technology, whatever. So you do your analysis and pick, the good one for you. And then of course we want to hang them in our CI/CD pipeline, our continuous integration and deployment. Ideally, how should the setup look like? Well, we have our repository system, we have our build street, right? When something gets being pushed there, ideally we want to launch Docker instance of things. Why is that? Because if we ever in the future want to replace this gentleman over here with, like, I don't know, Travis or some other thing, you don't want to rebuild your whole CI/CD, right, with the security and automation tools that you have. So you actually want to Dockerize that stuff. Then when you have a pull request, you kick the Docker instance, for example, the sub Docker, and then you point the sub Docker to your instance and say, well, go scan this new, push this new code that's being added. Then, of course, we need to manage all those findings that come out. So then we have another great OWASP project, Defect Dojo. That is a vulnerability management system where we then can manage and follow up all the vulnerabilities. Good thing also about the OWASP Defect Dojo, it has like more than 50 different adapters. So no matter what type of security tool you run, probably there's already an adapter for it. If there's no adapter for it, no worries. It's very easy. It's a Python Django application. So in like 2 hours, you have your own adapter. So even when you have custom other code quality, scripts, tools, whatever, it's even easy to build an adapter and also pull that into the one platform, right? Because the other thing we want to prevent is that, yeah, here, dear developer, you have a dashboard here for X, a dashboard there for that. You know, use Defect Dojo, you have everything in one place, and you can follow up all the findings. And if you really want to do it super nice, then of course you have a Kubernetes cluster that manages all the Docker instance, the pods and all that good stuff, right? Because sometimes pods die and crash, and yeah, so at least you have then a management layer which manages all those Docker instances. So this we all know, right? OWASP-SKF, awesome project, dynamic application scanning. So let's say we use this in our CI/CD. So how do we do it? Well, look how easy it is, right? Add 1 or 2, depending which type of scan you want to do. Add this one in your CI/CD as a task, spin it up, and boom. You just scanned your application using OWASP, the dynamic application scanner. Another one. Here, the dependency check. Another great OWASP project for doing libraries and components verification, right? Because we talked about technical debt. We don't want that stuff. So here you have another great OWASP project to put it into your CI/CD pipeline, spin it off in the Docker. Boom. It will check for you the libraries. Are you using any libraries with known vulnerabilities? It will be popping out and easy to implement in your CI/CD. Well, we also have something else, SAMGrep. So this is more like a static code analysis tool. Similar way, boom. Here is this, how you run it in your Docker. CodeQL, something also very useful when you have open source projects. You can use CodeQL and all the queries in it, and again, also run it in a Docker. OWASP-AMOS, another great OWASP project, right? For reconnaissance, DNS checking, and all that good stuff. Again, how do we do that in a Docker? Boom. So if you watch this video later back, yeah, you already can like put 6, 7 of these applications like that in your CI/CD pipeline, right? All thanks to the great people at OWASP who did these projects, who converted into Docker images, ready to use. If you don't have a CI/CD pipeline, run it locally, right? We only need Docker desktop, and you can even do it locally. Well, I also had to put this one in because we're talking about Docker and containers, right? So also there we do need to do verifications and manage, you know, what type of libraries and components and all that good stuff are in the Docker images itself. So can we also do that from Docker and scan? Yes, there we go. Okay. So a lot of good tools, easy, you know, to implement and to kick off. And like I mentioned, the most important part is actually getting it into one vulnerability management system. You don't want to give the developer, like I said, 10 different screens to follow up and manage vulnerabilities. A lot of, those security tools itself, they don't do any real vulnerability management, right? They just produce a list of vulnerabilities. So, well, you can choose where your metrics go, like Defect Dojo, Elk, Splunk, where you create maybe your own whole dashboard, right? If you want to be super fancy. But of course, the most important thing is, I would say, pick something that really works well. And of course, that is Defect Dojo. Because you can build your own stuff, but you don't want them to get stuck, right? Remember the previous slide, you don't want them to get stuck. And if you have these type of tools in your CI/CD pipeline, and they produce vulnerabilities, and we all know they will, you don't want them to get stuck. And if you cannot manage them properly, well, then you're a bit in an issue there. They will get stuck. So, one vulnerability management system to rule them all. Defect Dojo. Like I said, it's adaptable, customizable. Building new adapters is like peanuts in it, right? So even your custom tooling can be easily pointing to Defect Dojo and consume the findings from it. So here, for example, we did a dependency check scan on a library. So you get a nice list of vulnerabilities that it found with the severity, and then also the actions you can take and do. So you can say, hey, this one is indeed a real finding. I checked it. Oh, and this is a false positive. So let's remove it from the overview. Yeah. So you can really manage the true positives and the false positives. And it is quite important, as you will see in a bit. Well, also when you click on the vulnerability, you get more detailed information like, okay, it was this library, which was the function or the method that was maybe insecure. And then you can do your analysis to see in the code, hey, we're using this library with this method. Oh, okay, now I need to upgrade. If you're not using that method that is vulnerable, what should we do? Upgrade anyway. Why? Exactly, because we want to minimize technical debt. If you use an old library, it means you have technical debt. Imagine that you're using library 1 and the new one is library 4. Well, we all know what that will mean. I see some nodding, others like, well, what does it mean? Well, it means you have two options. Yeah? Your application will probably break when you go from the 1 version library to the 4. Yeah? So that means everybody, pizza sessions, war room, trying to fix your application. Or you just pull the plug, right? We let it die. Because some vulnerabilities are that severe that, yeah, if you have a code execution or whatever, I mean... So indeed, the gentleman in the back was right. We need to always remove the technical debt, update the libraries where possible. So that's anyhow a good practice, right? Also, when we talk about the whole CI/CD, you have different solutions, right? In GitLab, you have this nice flow that you can configure and put all these CI/CD tools in place with API that reports to Defect Dojo and all that good stuff. Similar for Azure, right? Also there you can build your whole pipeline and all good stuff. But, you know, all nice, we have all these automation and all these tools, but yeah, sometimes they're very obscure, right? What does it even mean, this finding? So that's also an issue. If the developer doesn't understand what the vulnerability is, so yeah, how can it assess then the impact and also the direction in how to solve certain things, okay? So learning and reading a lot, like the web security testing guide, the hacker handbook, all that good stuff is of course awesome to do. You will learn a ton of stuff and at least you will understand the jargon that all those security tools will produce. Well, the other thing is of course using the security knowledge framework. So that is one of the projects that, like I said, Ricardo and myself created like 7 years ago. And what we did here is actually combine every jargon, knowledge, information into one single platform. Also, what another good one is the Juice Shop. So the Juice Shop is basically like a super vulnerable application. It's also an OWASP project where you have, I think now it's around 130 different type of vulnerabilities that you can practice and learn. Right? And doing that stuff and learning will make you understand what the vulnerabilities are about. And also what the impact is, of course, right? But, coming back on all the security tooling, I mentioned false positives, but what does it actually mean, false positives? So what it means is actually that it will report findings that are actually upon very in-depth researching, not really a finding. Okay, so the security tool made a wrong guess and said like, oh yeah, this is a vulnerability, but actually it wasn't. So imagine you have a list of 100 vulnerabilities And from those, there's an X percentage that is actually not real vulnerabilities. But you only know when you inspect and do the analysis. So that's pretty shit, right? Now, the other question I want to ask you guys is, okay, let's say you are using SAST and DAS tools, the open source ones, the commercial ones, and you have a nice budget. How much coverage would you think we would have? And I must be fair that already saying 50% of the vulnerabilities we cannot find, right? Because they are logical issues, right? Business logic. There's no tool who can find a business logic. Take, for example, the IDOR, where you can retrieve, I don't know, data or files based on an identifier. If you change it to another identifier, you get somebody else's information back. Yeah, no tool will find that. It's all business logic, right? So, actually, we can already say here, well, it is not more than 50%, right? So it's somewhere between 0 and 50%. So what do we think? How much coverage using those type of tools do we have then? 8? Yeah, it is, well, okay. So I would say as a, security person, I would say, I hope it would be 50, right? But indeed, unfortunately, it's not. Another great OWASP project, the benchmark project, actually did this type of study and analysis to see, okay, how well, is the ratio between the amount of false positive, the true positive, and the amount of findings that actually are found. So, ideally, you want to be indeed in this left upper corner, right? Because there we have the least amount of false positives, and we found all the true positives. And basically, in the middle, that is like throwing your Magic of the Gathering dice and see, if it hits 7, yes, it's a vulnerability. Okay, it's random stuff. So let's see at the results. You see, it's quite empty in the left corner, right? And also, just to put it in perspective, let's pick here, I don't know, maybe this one, the M. So M, 20%, according to, well, what is it? 45. So that means, you still have to go through a lot of false positives to only get, a small percentage of that, right? With the true positives. So, am I now saying that we shouldn't use those tools? No, that is not what I'm saying. We should definitely use those tools, right? They are important. We can put them in our CI/CD pipeline. They can help us to do security better. But there's a big difference. What I'm going to say is, it should be your safety net. Yeah? It should not be your strategic vision. This is how we do secure and making the thing secure. No. This is your safety net. For when your people who went under training, used the requirements, did the pen testing, probably a lot of vulnerabilities will be introduced today on a Friday, right? When it's 3 o'clock, beer time, and, just do a quick commit, push it to production. For those moments, that type of stuff, you want to use, this safety net, right? So I just want to point this out that, yeah, there is a gap, but be aware of that gap, okay? That you should use those tools, but there's a gap, and you should deal with that gap. Now, also, of course, when we look at all the, patching, technical debt, yeah, why are we doing that, right? Because there's a lot of bots and automated attacks exploiting it. You saw it with the Log4j, people exploiting bots going crazy. So we need to do also something else. So now I stepped you through a bit through the whole software development lifecycle, the topics, the requirements. What else can we do that would be more effective? So what is the next silver bullet? Because, sorry? Assistance? Assessments. Yes. But I would say that is still in a later stage that you do not every time. Stake proof. Ad hoc. I don't know. So what would be effective? Developers, you are the one. You know, if I look at developers, I think they're actually, if you teach them, right, about security coding, some offensive security practices and all that good stuff, I think actually they're way better security people than the hackers. Because normally when I meet hackers, they don't really code. It's like a unicorn when I find a hacker who also can code. So now, the developers, they are really the one. Because these guys, they build like complex applications, functionalities, tie shit together that the business came up with, right? Well, if we empower them with the right knowledge, they will become a really cool, awesome security person that actually has context, right? So if you talk about SQL injection and they know, oh yeah, this, that, yeah, we need to use parameterized binding sub. But if you would ask a pen tester, hey, how do I solve it? Well, I found this vulnerability, it's not good. Right? So, difference. Developers. And, you know, also why we started actually the whole security knowledge framework like 7 years ago, because we saw over and over, we had like these deja vus. Oh no, again, an application. We owned it from A to Z. SQL injections, everything, command execution, cross-site request forgery, you name it. So we actually got really mentally frustrated, yeah, to have this stuff over and over again. And you know, the developers, they're not bad people, right? They have just a lot of shit flying through them, you know, feature. And actually, when we look at developers, they're Neo. They're awesome, right? They dodging bullets for sake. So, how can we help these developers, these awesome Neos, right? Well, luckily, there's the white rabbit to follow. And, like I mentioned, the security knowledge framework that we created. Really to help and guide people to do it properly, to do security by design, create the security awareness, and everything open source. Also easy, modifiable, adjustable to your needs, how you want to use it. So there we have it. I also want to do a quick showcase of what is the security knowledge framework. So basically it's an application like you see here, which has like tons of components to it. You can use it as a reference, right? When you're doing security, you want to have security requirements, then you can go to the checklist option. Here you have the checklist categories from the ASVS, the other great OWASP project, right? You have then, well, the architecture, design, threat modeling. So here are all the requirements that you normally should do for the architecture, design, and threat modeling. It also has different colors because it means different levels. The ASVS is built upon 3 layers, 3 levels, 1, 2, and 3. 3 is for mission critical stuff. 2, moderate. 1, this is what everybody at least already should have done. Okay, so if you're going to start with 1 because that's your technical depth anyhow. And those agent Smiths, they are already running and ready to kick your ass because you didn't implement those level 1 requirements, okay? So you can use this as a reference, the checklist. Also, like code examples. So here we have just a detailed overview of how to do audit logging or setting headers or whatnot for like 4 or 5 different languages. The most common use functionality that you would write as a developer, are in here. As you can see, we wrote this quite some time ago, so we didn't review it lately. If you're good at .NET or a couple of those program languages, please have a look, because we need also to review them again. So we have the code examples. Well, knowledge base. Why do we have a knowledge base? Because, like I said, there is so much security jargon, right, that sometimes even the security specialist doesn't know what we're talking about, or what does it mean again. And as you can see, it's huge, right? So it's also not weird that developers don't understand sometimes things, or even myself, right? When we talk about a very specific item. So here we have a nice list which you can search through and have some understanding. Okay, what do we mean with it? Something that we already had for quite some time, but now actually, okay, I have no internet anymore. Who can slaughter a goat for me? I forgot to do it, sorry. Yes, thanks. So here we have the labs. This was something that we already had for quite some time. And what you can do here is basically start the Security Knowledge Framework labs. It's like a tiny application that only has one function, and in that function is a vulnerability. Or you can say, hey, you know what? I'm actually ready. I did all those things. I want to do a juice shop. So you can also just click here, start juice shop, and it will deploy in your Kubernetes a juice shop instance. So let's see how it works. Normally you press start. Now little midgets, are very hard working in the background, building this Docker image, throw it in the Kubernetes cluster. So it will be available for us to use. So you get a nice URL back, and when we go there, you have the tiny application running. So here you can, practice your skills and your whatnot to improve your security. So bonus question. We have here, what is it? We have here a drop down. We can select something. Okay, different text that will be pulled. So it is a local file inclusion. So what should we do now? Anybody who has an idea? So what do we see here? We see a value, text, slash, and then a file. So is that good? Is that bad? It depends, yes. That's always my favorite, best answer, right? Because it always depends, when we're coding or doing security. So if you want to give a good answer, you always say, it depends. Because it's actually very correct. So, of course, the lab says, hey, local file inclusion, right? So, let's do the path reversal and go to the root and then the password A. So, now I change the value of the intro to the password A, and when we do submit, ta-da, it works. Okay? Sorry? Yes, well, that's advanced stuff. We could have done that yesterday in the workshop. But, sometimes you actually, for local file inclusion, you can also use the direct path. Because, like the gentleman said, it depends. Oh, and I made a typo. It depends how that functionality is implemented, right? There are not really tricks in hacking and doing security. There's only understanding, right? And when you see the code, you will understand, and that's why you understand, like, hey, we can use the path reversal, but actually, because it's just a file open with our input, we can also just say /8 if say password A. And when we do that, we also get the file back, right? Because it depends. So, anyhow, here you have the nice environment to do the labs and play with it. Maybe you're like, okay, well, this really goes above my level of knowledge. Then you can go to the write-ups, actually. Currently, we have Python, Node.js, and Java labs that you can run. They're all the same vulnerability, but in a different programming language. So that also, when you're a developer, you can fix the vulnerability in your own language, right? That we're not enforcing you Python, because it's awesome, but we're not enforcing you Python to be used, yeah, but you can also pick one of the others. And how will it look like? Basically, it will say like, here, blah, 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 this is how it looked like, here you should look at, this is interesting, why is it interesting, and this is how you can exploit it, basically. So that's the steps and the reasoning, so you can do it yourself. Well, now, also the other thing in SKF, what we did, we actually created an expert wizard. Because, as you probably know, for example, the ASVS and the MASVS, they are like huge set of security requirements, right? I think the ASVS has like 290. So, if you would print it out, it's like a book, right? And I don't see developers carrying around a book with security requirements around. So, yeah, for that we wanted to make it again easier for developers. So what we did is actually create a sort of expert wizard, which you can go through, that then based on the questionnaire, it gets context, and because we have context, we can say, then you should use these requirements. So that is basically. For example, here we have already a list. I see some people already tried it. And basically what it will do, so let's say you're a developer and the manager comes and says, yeah, we need feature, a search function on this website. Can you go fix it? Of course, dear manager. Let me see how much extra non-functional security requirements will be there, right? So, web application, next. Then the level, well, maybe it's a very critical application, so we say 3 for now. And of course the category. So here you have an overview and you see, okay, well, I'm going build feature X, so which type of categories would be interesting then? Well, I would say like the validation and all that good stuff, right? Because we're going to take user input and display it somewhere. So we pick that one, next. Then we get here like the expert system. So it's going to ask you a couple of questions like, hey, do you want the input validation? Well, yes, because I don't know, maybe I didn't have yet a central solution somewhere in my framework that already did this, right? So maybe I'm like, input validation, what is that? Okay, so that's good that you use this SKF and this flow, right? I'm also going to output, because I have search, I'm going to output it. I'm also going to do some SQL, because I'm going to search in the database. And all the other stuff, no, I'm not going to do. Next. So here, what you can do is 2 things. Now we're going to create a new feature, because we're going to create a feature that we want to release, the search function. But it could be that maybe later, that feature, because it all happens, a manager comes back, oh, by the way, we also need ABC. So then you can go back to the same feature and enrich it with also the other categories, if needed. Yeah? So then you can say existing features, and then the requirements would be placed into that structure. So search, new search, func, next. So when I now press submit, what it will do, it will actually then correlate all the 290 security requirements, and based on the questionnaire, it will say, oh, okay, only from the 290, you need these. So instead of you going through the whole 290, just by doing this wizard, you get already the right requirements from the ASVS. Now, what is also important, you should always, of course, tailor and modify the ASVS to your need, right? Because the ASVS really is super broad, very in-depth, to cover most of the higher business, but also for lower. So you always need to tweak and modify the ASVS to your needs. And also in SKF, you can do that. You can even build your own checklist. So if you say, well, all nice, but we have a very specific stack or thingy, just go into the management, build your whole checklist, your questionnaire, your expert system, and then you can use it in a similar way, right? So now we have all these findings, and, before we start programming, now we have our security requirements that we should now include in the sprint planning, in that feature, to say, okay, so you wanted a search function? Well, look at this. This is also what we need to do, right? Input validation. Sometimes protecting against mass parameter assignment attacks, that all the input has been properly whitelisted in validation. Strongly typed. If you do URL redirects, be careful. JavaScript to prevent cross-site scripting, right? Setting the right local. The context-aware approach for DOM-based and stored cross-site scripting protection. Make sure you're protected against any form of QL, SQL, NoSQL, PQL, whatever type of injections, right? Use parameter assignment. And again, cross-site scripting, and use the content security policy and so on. So here you have the whole list to get you going. So that is really awesome. Now, the other thing that we actually did, and this is what I've been working on for the last weeks with actually people from my work, ING, who really helped me a lot there. People from Microsoft, OWASP, OpenSSF, like really a lot of people were involved into this. And that's actually really a sort of training platform. Because as you saw, you could already train yourself, spinning up a lab and okay, you can hack, which is nice. But actually, we thought, you know what? It can be better. Yeah. So what we did, we actually defined already 4 different categories, profiles we call them. So we have the secure development profile, hacking web API, infra ops, because also, the stack and the infrastructure is very important. So this is a bit like OSCP, VulnHub type of images, but not that in-depth like OSCP. Because, again, this is for awareness and improving skill level of infra people. So we're not going to do buffer overflows and all that stuff because, right, that's not needed for their part. But it's a key component, right, in the whole software development. Our applications run on Stack, so also they need to be aware. So that's why we also created that track. And of course, my favorite, OWASP. So as you can see, we already added one OWASP learning track here, the OWASP Top 10 2021. But in the future, I actually want to extend this with all the cool OWASP projects. Oh, you want to do dependency track? You know what? Here is a whole README and tutorial, how it works, what to do. Oh, and by the way, here's a box, a real operating system box where you can run it, play with it, and try it yourself. So that is, to do, upcoming, to add this and put all the amazing other OWASP projects in, like OWASP, for example, and so on, right? We could even build here an interactive learning track. So how does the learning tracks look like? You can start it, and basically, it's next, and you enter, right? So, or enter, and you enter. Sorry for the Dutch. But anyhow, so the idea is we have over here the whole tree of the course and what type of stuff is in there, right? And basically we can go over it. There's also this per main topic, like a video that can be then loaded into the thing. If you want to see it full screen, boom, you can also do that. So in the future, we will also add, like, for all the topics that we have in those learning tracks, videos, because sometimes you want to just, explain a bit better, and more the general topic in a video. So you get that, and then basically you can jump into the next section, basically the content, right, of the project of what we're trying to learn. So all good stuff. Next. Oh, what's up? Also awesome. Next. Yeah, and basically now here are all the topics, right, of the OWASP Top 10. So you can read this nicely. If this is too small, full screen. Again, you can read and educate yourself. Okay. Now, this is not all. If we then go to the, I think here, next steps. So you have now also the button Start Lab. So what we are going to do, and we already mapped quite some to topics, is, I showed you, we have a huge list of labs actually. So we correlated them to topics, and now you can do Start Lab, and it will actually deploy like a Debian-based operating system with already installed the OWASP, a code editor, a Firefox browser, the dependencies for Python, and all that good stuff. So here now you have a browser-based operating system where you have already all the tools in. So you can follow the whole course and do everything just from your browser, right? So how would it look like? Well, like this. Now you have just an awesome Linux terminal. You want to start Zap. Here, there you go. Let's start Zap. And this is the real proof of the pudding, if you can start Zap. So as you see, by default, Zap is in there, works like a charm. And then, yeah, well, the idea is, of course, that you that you can go to, well, let's go to the local file inclusion. We just did that one. Yes, indeed. The port was already in place, but that's also good. Sublime, because that's the other part, that you have a full operating system where you can also fix. And because, the normal flow, I would say, you as a developer, you do the hacking, you understand the vulnerability, and then you go open the code and fix it, right? And then when you did the fix, you can actually just use the knowledge you got before, right, on how to hack it to do the verification. But of course, let's also use ZAP, because that is also a verification tool, right? To see, did you really solve it? So, open folder, home, labs, LFI, open. Let me change this to port 8080. Do I have the right one? Maybe not. I'm not sure now. Control S, saved. No, okay. I didn't pray to the demo gods, unfortunately. But anyhow, I think the idea is you get the idea, right? So you have everything. Some different desktops because it gets quite cluttered. So you have like a fully operating system inside the browser where you can do all the labs and the challenges. So, well, this was only the OWASP track. We have also the whole secure software development track. This is actually created by David Wheeler, very in-depth, very good one for secure software development. Then we have the hacking web API. Again, a very awesome project. It's from the OWASP testing guide, right? We all know that. The standard for how to do web application and API security testing. So all the knowledge and information are actually, again, presented here, how to do certain things, right? Explanation, all that good stuff is here integrated. And again, if you hit certain topics where we already have labs for, then you get after the questionnaire, because, okay, yes, you read a lot of content, but we're also going to challenge you. Did you really pay attention? Did you grasp the right and the important key topics? So you have also a nice questionnaire. And when you did all the questionnaire, then at the end, you will have then the option, start lab. And you start the lab and you practice what you just learned. So, that is basically what we're now doing. We have not pushed this yet to the main repository of SKF. It's now in a separate branch. Like I just showed you, there are some tiny quirks that we want to fix first. Also, for example, when you're in the OS lab environment and you press minimize, then it's gone forever. Yeah? So there are some things that we're going to fix. So at least we pushed it to the demo side to get that feedback, get some bugs reported. So then when we have a good fix for those, we push it again and to the main branch. So everybody's also able to run and deploy it. So one last thing, how would you run and deploy it? Well, you can use any of your favorite Kubernetes platforms, or you can just use Docker Compose up, and then the whole thing I just showed you will run locally on your machine. So that's it. There's also the capability of adding very easily your own material. How it works actually underwater, there's a YAML file with some tags that will say, hey, it's this lab, it's this markdown file, it's this topic. So just by writing a YAML file and adding it, we can implement and add a whole new course to it. Of course, the material needs to be a markdown format, but hey, everybody is doing that nowadays, so that is not really an issue. Okay, who is fishing me now? Let me see. What? Now I'm wondering if it's this email or the other. Is this one? Yes. Whew. Normally this is the magic finger, right? But I don't know, didn't work. Tip. How far was I, Sost? Yes, follow the rabbit. We did follow the rabbit. Boom. Okay, so we're here. We're almost done. Then you can have something to eat. Bear with me. So really important setting the right requirements, right? I mean, we can have the security tooling and some awareness, but, again, if you don't use security requirements, it's already lost, all your effort. So please do it, right? And again, we have very good projects for it. The application security verification standard, or when you're doing mobile applications, the MASVS, super good projects to use for that. Like I mentioned, different levels. Level 1, opportunistic, like I said. Level 1 is something you already should have done. Probably you're now already being hacked and owned because you didn't do the bare minimum. Okay? If you really have a critical application, use the level 3. Well, of course, like I mentioned, you get probably lost with all those requirements, right? So, hey, the security knowledge framework, you can use the expert flow, the wizard, get the right requirements. And again, it's really about, having all those threats visible up front, right? Like Neo, that he could see the agents. There was no, right? We want that too. We want to see and be aware and spot the vulnerabilities. Yeah, and how would it normally look like? Well, we have our usual stories, right? Hey, as a new user, I want to do a registration. I want to register myself so I can use the premium. And normally the acceptance criteria is something like this, right? 3 bullet points, like, oh yeah, with the first name, last name, a phone number with this format, and the date of birth. Well, awesome. But when we then look at the security requirements, boom, this is only level 1, what we should do. And again, even if I, myself, am in a meeting and somebody would ask me, so Glenn, what requirements should we use? I don't know. Look how many there are. Am I like a walking dictionary or no? So you need something that really is like, has a method, right? And a structure that, you don't forget anything. Because again, if you miss one, that can have huge impact, right? And here, this would be the additional ones if you do the level 2, right, that you want to include. So now suddenly you have a huge, pile of work. That's fine. But the other people, like managers, product owners, also need to realize that, right? If you would ask me, Glenn, build a file upload function, I'm like, okay, 1 minute, I have it for you. If you would ask me, hey Glenn, build a secure file upload function, 3 days. Right, that's the difference. So, and again, it's all going back to what is the level of quality you want to have for your product that you're developing, right? And of course, security should be and is super important, but just ask the overall question, how well and how much quality do you want? Here another one. Well, like I said, uploading files. Well, here, 1 minute I said, right? Because this is what you would type in Python Flask to do a file upload. Is it true? No, to read a file, I think. This is for reading a file, not uploading. But almost the same, 1 line of code difference, you have a file upload. But then, if you look, at the requirements, there are, of course, way more requirements going on to be added. Reading uploaded files. So what will this do? Bonus question. What is the vulnerability in here? Upload here, XML. Oh shit, no, go back. Upload XML. We're going to parse the XML. We check the elements. They need to exist. And if so, we convert it. So yeah, here's just a big ass external entity injection in it, right? So again, you can build very quickly features and functionality, but again, to do it in a safe way, yes, that takes a bit of time. I'm not sure about this one. Probably it was about if you do find vulnerabilities, you also want them to be included in your testing approach, right? Making sure that those vulnerabilities that were found and you fixed will not occur anymore in the future releases. And you might say, well, that's actually a bit weird because you fixed it, so why would it reoccur? Because people merge old versions or old snippets, old branches, so you do hard work, you fix the vulnerability, and 2 releases later, that thing is back, right? So using the different approaches, Selenium, I don't know what, unit testing, we can include that in the pipeline and making sure that we have proper regression testing against those vulnerabilities that we solved and found before. Yeah, and now, what I truly believe, the neos, the developers, you have now the skills. There's no need to dodge bullets anymore, right? You're neo. You can just stop. Thank you very much. That was my talk.
Thank you. Thank you, Glenn. Any questions for Glenn on this? Or are you all eager for lunch?
We all want to eat. No?
All right. So thank you again, Glenn.
You're welcome.
Thanks all.